Alright, in my last video I ported 3 basic programs that I had worked on the channel over the years to Vision Basic. Since then, Dennis Osborn has taken a look at them and he looked at my programs and he's like, yeah, that's nice, but I know I can do better. Essentially, he's optimized all 3 of them in Vision Basic using his techniques, and the results are amazing. In this video, I'm going to go over those results. We're going to take a quick look at the code and the methods that he used to optimize the programs. And on the final segment, we're going to go ahead and redefine the character set of one of these basic programs and turn on an animation and basically get the building blocks for a game in place. All right, so let's take a look at the first program that he optimized. We'll start with the slow version, the one that I just ported, which I thought was adequate, which drew this map right here, or this maze. It takes a few seconds and it draws a maze. And I thought that was pretty fast. I was impressed with that. Then when Dennis got his hands on it, he was like, here's how fast it should be. Much quicker. I would say at least 2, maybe 3 times faster. Oops. So that was the first one. We'll take a look at the program code after we look at the programs. The second one was the little pack game, or the little pack beginning of a Pac-Man type game. And I thought this was quick. And as he zips around, he eats the dots randomly, moves around the maze. It's hard to see, but he was a little dude moving around. And then Dennis Osborn's version, it's just magnitudes quicker, right? Maybe 5 times faster than what I had came up with. I'm just blown away with what you can do with some machine language optimization, style optimizations, but in basic. And then finally, the third program, which I thought was quick compared, especially when you compare it to regular basic. You kind of just move up, down, left, and right. And I didn't really optimize these, obviously, not the way that Dennis can. But that was that one. And then Dennis's version which is night and day. So you go up, down, left, right. And it's so fast you can't even it's too fast. So those are the 3 programs. Let's take a look at the program code though. This was my version of the maze program. And let's see, this is kind of just a refresher. Take a quick look at it. And then we have Dennis Osborn's fast version. And some of the things that he did on this was he took the multiplications that I did, and instead of multiply them straight out, he would double them. 2, 4, 8, 16. And he basically making optimizations to the way the math was done in order to improve the speed of this program. That was the main thing he did on the maze one. Then if we take a look at the pack program, this was my version. Essentially, the meat of it is right in here. And then we'll take a look at Dennis Osborn's version. Now, one of the main things that Dennis did on this one, instead of calculating a random value, like I was doing in here, I mean, he's still doing a randomize, but he wanted to eliminate this multiplication. And he did that with this little table, and he used some sort of a technique to calculate a semi-quasi-random number. He also eliminated, I had up, down, left, and right in a string, and he changed it to a numeric for performance purposes, and that really sped it up. And then on the third one was where you move the maze, the Zeph one, where you move up, down, left, and right. This was my version, which I thought was pretty clean and pretty optimized, but it's definitely not optimized as compared to Dennis's version, which is multitudes faster, probably 10 times faster. I don't know, but extremely faster. And I think he used similar techniques here with his multiplications. And I can't speak of anything obvious that he did. Now, he did send me an email on the maze one where he wrote, I added a routine to the maze program to perform some multiplication faster. If you have some multiplication to perform and one of the values is always the same and not too big of a value, you can design a routine that will do the job faster than letting VB handle it. So when it came to multiplying a value by 80, I added these lines. So he added these lines right here, which effectively multiply the value by 80. It was really clever. And then also here on line 1530, he wrote, they effectively multiply the y variable by 80 and then add in the 1024 and x variable. Notice that the 1024 variable starts out as 512, but then it gets doubled after being added into everything. So those were the programs that Dennis optimized. So on this segment, what I wanted to do is take Dennis's optimized version. I wanted to redefine the character set, and then once the character set's redefined, we could sort of set up some animation. Since we don't have anything past line 2200, I thought I would start off at line 3000. And in line 3000, we will do a copy set command. What this does is it makes a copy of the character set and puts it in the location of your choosing. And the first parameter is between 0 to 31. And we're going to use 25. And we're going to use comma 1. 1 is to put the character set at lowercase. It's an optional parameter. And then in line 3010, we're going to go ahead and use the charpat command. And what the charpat command does, this essentially tells the Vision Basic which character you're about to redefine, because we're going to redefine what I wanted to call the water character. So we're gonna I'm not sure what character that is, but right now, we're gonna go call it 0, which would be the @ sign normally, and then we're gonna modify it character set 25. In the back of Dennis's book, starting at page, was it 261 with the video memory breakdown in Appendix D, he breaks down what the memories look like and what the Charset, which character sets go with which screen values. And so you can kind of look through there to kind of help pick out where you want to put things. And then in line 3020 through the next set of lines, the next 8 lines, is where you actually define the character set. And you do that with the code command. So if you say code, and then if you were to, you can put an X represents a 1, and then a dash represents a 0. So if you went 1, 2, 3, 4, 5, 6, 7, 8, that would be 8 zeros. Essentially, if we did this 8 times, see how many times I did there. It's like, need one more. Okay. And then you can draw in your, and I sort of have an idea in mind. And this is where you kind of let your creativity come to play, and your artistic. Let's see. Oh, do I have one? Oh, you know, I got to do this one line down. Okay, so that's what I envision for my water character. All right, the next line we have, this is probably the most important line here for redefining the character set. We have to move the screen, and it has to match an area of the memory where the character set is. In his manual on page 265, you can see there's the character sets bank 3, character set 24, 25, 26. I was using 25, and I thought I would use screen location 48, which is the beginning of the character set, at 49152. And to do that, you just use the command vid location. You tell it the first two parameters is 48, 48, and then 25, which tells Vision Basic where in memory to locate your screen and the character set. And then with that, to do a quick test, we could print out a character. So if we were to go A, B, C, D, E, F, but then if what the character we're redefining is 0, which is this @ key, @ sign, kind of wait for you to press a key, and then we'll have to jump to it. And then, when we'll probably want to clear the screen here also. Oops, CLS to clear the screen so that we have a clear screen. And we need to call the sub at 3000. Oops. So at line like 10, go sub, and we'll just call it and then stop the program. Let's see what I did wrong. Oh, it's vid lock, not vic lock. So you see right there, I have my characters, they're lowercase, and the redefined characters is right there. Now, if we wanted to play around with it, it's really fun to go around in here, and you could just put some X's wherever you want. Just to see what it looks like. You could experiment around. That looks bad. But you get the point. It's easy to fix because the last two are blank and the ones in the middle were blank. Now the idea that I had was to just go ahead, once you have them redefined, was to be able to animate those that water. I'm calling it water, but to animate it moving in a downward motion. And that is the next step. So I think I'll put the next part in. I don't know, I'm just going up 1,000 because it's like start my subs at 1,000. But we'll go to 4,000, and we're going to do a quick routine that loops through that memory area. And the character set, let me look at 265. Character set 25 starts at 51200. So keep that in mind. So we're gonna do like some assembly here. We're going to load our X register with 51207. So 51200 is the top, the very top of that character, and then 07 is that last byte. And then we're going, that's just to save it off so that we can set it to the first position. We're going to load our Y register with 6. And then we're going to load 51200, comma Y, store it at 51201, comma Y. And we'll change these to labels momentarily, but I just wanted to show how this works. We're going to decrease y. We're going to branch if positive, back up one line, 4010. After we're done, after we get out that loop, we want to take what was on that last byte and move it to the top byte. It's part of scrolling it. So we're going to store that X register that we saved off at 51200. And we'll do a return. So if we were to call this, if we shift it once, go sub 4000. Oops. If I wrote that program right, it should shift it one time. And it's hard to see that, but I believe that worked. In order to see if that's working, we'll do it in succession. Do it a couple times. So every time I press the button, any button, it should scroll it. Okay, starting to see that. So now that that's sort of working, you'll notice that, and when I'm looking at 4000 on, that I have 51200. I have that used in a few places. It would be better to sort of use a label for that, so that you could easily go back and change that should we decide to change the character set. So in order to do that, let's move this up a line, and let's change line 4000, and we'll create a tag. Like ch equal 51200. And then wherever 51200 is, we'll use ch. Like in this case, it's ch plus 7. In this case, it's ch. And in this case, it's ch plus 1. And then here, we're back to ch. Let's see if that works. Okay, so that looks like it's working. Oh, okay. Let's see. When the program ends, let's list. When we end the program, it's a good practice to switch things back to normal. Although Vision Basic is handling it, there is a command to switch things back to normal by using the normal command. Switching it back to normal meaning going back to your character set at the normal position at a 1 or 400 hex. All right, so now that we've got it working, we can get rid of line 3130 and let it return back. And then instead of ending the program, we won't end the program here. We won't even do the go sub. We'll get rid of line 10. Okay, we'll get rid of line 10. And what we're going to want to do is, let's find the main program loop. A equals peak of 197, which grabs the keyboard input. Go to 1780. So line 1900, let's modify that one. Go sub 3000. Now let's see if that works at all. You see how fast that is? Okay, wait a second. I left in a print statement. We got to take that one out. I think that is line 3120. Oh, yes. It's not going to run straight away like this. Because I've repositioned where the character set is. And there are some pokes in here. The pokes are, in this original program, it was assuming the screen was at 1024. But now, if we look at, what was it, page 265 in the manual, the screen has been moved to 49152. So on line 1982, we have to change this. Instead of 1024, this needs to be 49152. I have a clear screen or something in there, don't I? Something's weird. Something's weird with that. Hold on. We'll figure that out. Oh, yeah, I can't do the clear screen anymore right here. Okay, there. Now we're back to normal. Okay, we can't do the vid lock every time. Okay, we can't do some of this stuff. We can't be done in the routine. I see. I just got to restructure it a little. We'll get there. We'll get there. So the vid loc. You're going to want to call this one time. Call this to redefine your character set one time. And then call this shifting every time. That's what I'm doing wrong. So bear with me. Sorry. Hold on. I meant for that to be go so 4,000, but then at the very beginning we want to maybe at line 10 go sub 3,000 to redefine our character set, and then in the program loop go sub to 4,000 to shift. Otherwise we get those weird results like what we were seeing. Okay, so now we have the water. It's moving every time in the loop. Hold on, this is weird. It shouldn't be saying done up there, and that's what's bothering me. Let me fix that. We have the CLR, CLS, so it's clearing the screen. Then it's go sub into 3,000. Redefining the character set. I don't have an RTS. Okay, I don't have an RTS or a return. That shouldn't matter. I gotta do that. Put that back. There we go. Okay. That's my water. It's moving way too fast. We have to slow that down. What I thought I would do is I would set a variable that would only execute this code at 4,000. You know, every so often. So maybe put this at 4004. And then at 4,000, I'll have a variable like a delay or a cycle or something. Cycle equal increment cycle. If cycle is equal to 100, then cycle equals 0. I don't know if I could just put the line number here, 4004. And then at 4002, we do a return. And then that should execute it only every 100 times. Let's see. All right, so it's not moving at all. Hold on a second. Let's make sure if I have to say go to. I'm not sure. Hold on. Bear with me. Oh, I guess you do have to say go to. All right, so now you see the shifting, the water. You could speed that up by adjusting that variable. All right, then one more trick I wanted to demonstrate, or it's not really a trick, but it's a technique that Commodore 64 programmers use to determine where the raster is. What you can do in a program, let's say you want to know how long or how much cycle time a certain part of your program is taking. What you can do is you can go in and we can what we want to do is go in and put in the pause command. This is a Vision Basic specific command. What it does is sets the raster off the screen somewhere, but it will only continue executing after the raster has hit that spot. It's a very minute or very minor pause, and I'll put it in right now just to show. You probably won't see a difference in the speed or execution. You see everything looks like it's running the same. Hit Q to quit. But what we can do is we can go in, and it's right before our program starts running. Right here, we can say increment 53280, which is your border color. And then when it's done executing here at the end, we can say decrement 53280. So basically you change the color value and then you subtract the color value. And that'll show us where the raster is. Oops. Ah, what am I doing? There we go. Oh, that's interesting how it's moving around. So anyhow, that is a tip. You can kind of see the pause command itself. You can actually specify seconds or jiffies is what it says. Yeah, if you were to specify a second, that would be way too slow. But anyway, that is used to sort of level out programs, to start them so that your sprites won't jumble around or have flicker, to reduce your flickering. But may not be necessary in this program, but I just wanted to show that, and I'll probably strip it out. The other thing you could do in this area of the program is instead of doing a loop, you could just do an LDA, STA, LDA, STA 8 times. But I prefer to do the loop. You can see where you could have a lot of fun coming in here and just redefining a bunch of characters, not just one character is all I've demonstrated in here. And you could have all sorts of little animations based on whatever you require in the program you're making. So anyway, I am going to post the source code for all of these optimized programs up on my GitHub. What you can do from there on the GitHub is take a copy of them and then copy paste them into Vision Basic if you wanted to play around. So anyway, you could see where you could just modify the program. It's really fast, so you can modify this fairly simply to maybe add in color values for all the different characters based off some sort of table or whatever your preference is. Taking one final look at the program, that is my video for today. I hope you enjoyed watching. Hope you could have gleaned something from it like I did. And I wanted to thank Dennis Osborn for sharing his insightful optimizations with us for this video. It was amazing bits of optimization that he was able to accomplish. All right, thanks for watching.